All right, just like geometric, there are, in that same position, there are buttons in your calculator that you are going to use to find the binomial probabilities. You've got binomial PDF and binomial CDF, just like we had for geometric. Binomial PDF gives the probability that you will have X successes in your N trials. Binomial CDF, that cumulative, means that you will find probability of you finding at most X successes in your N trials. So this is like less than or equal to. Same thing as geometric. They mean, those C and the P mean the same thing, just like they did in geometric. So it's just a matter of you deciding, is it just something like, what's the probability we have 4? Or is it what's the probability we have 4 or less? Or at most 4, same thing, okay? So it's just a matter of deciding which one you're talking about. Recall from earlier that 91% of our emails were spam, so that meant 9% were real messages. Suppose that your inbox contains 25 messages. This is N. We did not have this number the first time we were looking at this problem because we were talking about a geometric model. And even if I would have told you you had 25 messages, you didn't need to know that number. For the geometric model, when you're looking at the position of the first success, you don't need an N because you're just going to keep going until you find the first success. You don't need an N because it doesn't matter where that first success falls. You're just looking for the first success. Now we're looking for the number of successes in a set number of trials. So we need to know how many trials we're talking about. In this context, we're now talking about 25 trials or messages now. What's the mean and the standard deviation of the number of real messages, number of real in your inbox? So that's how you know you're talking about the binomial model, because we're now looking at the number of real messages or emails in 25, where inbox has 25. So it's the number of successes in a set number of trials, as opposed to the position of the first success. I'm not looking for the position of the first. I want to know how many reals do I have. So it's always binomial NP. N is 25, P is 0.09. That's the probability of success or probability of a real message. This one is asking me for the mean and the standard deviation. So the mean is equal to NP, which in this case is equal to 25 times 0.09. Type that in my calculator. And I'm getting 2.25. So I would expect about 2 real emails in my 25. With what standard deviation? That's the square root of NP over Q. That's the square root of 25 times 0.09 times 0.91. And I'm getting about 1.43. So with a standard deviation of about 0.143 emails. Obviously, once again, we can't really go 3 standard deviations below the mean because we'd end up with negative emails, which doesn't make any sense. So that should give you an idea that this is most probably a skewed distribution, skewed to the right. Kind of like when we did Randy's simulation, it was not as badly skewed because the mean was much higher, but it was slightly skewed right as well. What's the probability that you find only 1 or 2 real emails? That would look like this. Find the probability that X is 1 or X is 2. If I wanted to, well, like this is how I should probably do it. We learned earlier that when we have ORs, we can add. So I'm going to find the probability that X is 1 plus the probability that X is 2. Now to do this, I'm using technically that formula that would look like this. 25 choose 1 with probability of success to the 1, probability of failure to the 24. So this is how many different ways you can only have 1, and then this is the likelihood of having 1 and then having 24 not, or spam, plus 25 choose 2, that's the second one here, times 0.09 squared for 2 of them times 0.91 to the 23rd, meaning you have 2 real and 23 not real. This is just, you guys, you don't even need to write this, to be honest with you. I'm just trying to give you some sort of an idea of where these numbers are all coming from. If you, but listen, it's very important that you have everything else written down, that you have the model you're using. You told me what X is. You told me what you're finding the probability of. Now I really can just do this in my calculator using, since these are equals, using my binomial formulas, second VAR's binomial PDF, because they're equals, and then NP X. And the first X was 1. And I'm going to repeat this, close out my parenthesis, add it to another one of these, binomial PDF, NP, and then the second X was 2. So I'm finding, each one of these is finding this one, and then we're just adding them together. And so that answer turns out to be 0.5117, or there's about a 51% chance of you having 1 or 2 emails, real emails in your 25 inbox. Some of you might be thinking, why didn't we just use CDF? Binomial CDF, 25N, comma, P, 0.09, comma, 2. X, because that would be 2, at most 2, so it'd be 2, 1. Notice we get a different answer though, we get a little bit more because this also includes 0. So what this is doing, it's doing at most 2, so you could have 2 real, 1 real, or 0 real. This question didn't ask me for 0, it specifically asked for 1 or 2 only. So it's not exactly the same thing as using CDF, because I did not include here the 0. If I would have added another one, binomial PDF 25.09, comma 0, I'd get this number. Okay? So just be aware of when to use PDF and when to use CDF. I could have used CDF, but my answer would have had too much in it. I would have had to have taken that 0 out.